Okay, Mr. Robinson, let's talk about these angles here. I think this angle I can see is bigger than a right angle, bigger than 90 degrees, but smaller than 180 degrees. So that makes it an obtuse angle. But I wonder how big it is.
Well, I think I'll make an estimate. I'm looking at that, like you said, it's bigger than a right angle, smaller than 180. I'm going to say that's about 140 degrees. That's my estimate.
Right, so now it's time to measure it. First of all, Mr. Robinson, you need to put your protractor onto the angle so that the lines cross where the lines cross on the protractor.
I'll make that a bit bigger for you there, Mr. Tite.
Thank you very much. I can see it now. Now I can see the zero line is in line with the zero line. Just give it a little bit of a wiggle there for us, Mr. Robinson, so we can see that the zero line is in line with the angle. And now starting at the zero on the right-hand side, we can count round 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, and then getting really close, we can see that the line stops halfway between 130 and 140. So our angle is 135 degrees. And thinking back to our prediction, we said it would be between 90 and 180. So that's correct.
Well, my estimate was actually 140, so I was very close. And I think we can safely say that that must be the correct answer.
Very well done, Mr. Robinson. Have a pat on the back.
Right, shall we have a look at the next one here? Now, this angle is going in the other direction. What do you make of this angle here then, Mr. Tite?
Oh, this angle looks much smaller, Mr. Robinson. From my experience, I can see that it's much smaller than 90 degrees. So we can call this one an acute angle. It's nice and cute and small.
Very nice.
So with a prediction, I'm going to predict this time, Mr. Robinson, it's smaller than 90 degrees. Looking at it, I think it's about halfway between 0 and 90 degrees. So I'm going to estimate an angle size of about 45 degrees. It doesn't have to be bang on, but I'm predicting that to give me a guide as to what to measure so I know whether my answer is roughly right or not.
So once again, I'm lining up the baseline exactly there and those crosshairs right onto the angle I want to measure. And now I'm going to look at the scale here, and I must remember to start from 0 and counting up. I don't want to look at the inside scale, that'll give me the wrong answer. So what was your estimate again, Mr. Tite?
My estimate was 45 degrees, Mr. Robinson.
Well, just looking at this, I can go 10, 20, 30, 40. I'd say you were wrong actually, Mr. Tite. It's about 43 degrees.
Oh, I think I was even closer than you, Mr. Robinson, was I not?
Very good estimate, Mr. Tite.
And even though my estimate isn't exactly right, that's okay. It's told me that I was pretty much in the right area and that my measuring is accurate.
Okay, one more to look at. Now, I'm not sure what you're going to make of this one, Mr. Tite. What could you tell us about this angle here?
Ah, well, this angle, I can see a special symbol on this towards the bottom of our diagram. That's the right angle symbol, which tells me that this angle is 90 degrees.
And it will always tell you that it's 90 degrees.
And therefore, I don't even need to use my protractor to measure this one.
This is a right angle.
So today we've looked at obtuse angles, bigger than 90 but smaller than 180 degrees.
And we've learnt how to use a protractor by, once again, if you remember, using our 0 line to line up along the bottom, making sure our crosshairs are exactly in the right place and making sure we use the correct scale to measure our right angle. And we mustn't forget that our estimates are ever so useful for just checking that we've got an answer which looks correct.